So let's have a look at special permissions. Some people have problem understanding set user ID. As I explained, set user ID means that the descriptor executable is run with the permission of owner of the script. So let me do an example. Let's go to the home directory of user Lisa by typing cd/home/Lisa. Let me create a nice little shell script called game. So with every shell script, it should start with C1. That indicates it's a shell script. And then we frontally say, hi, do you want to play a game? We have to shell script wait and completely ignore the answer and execute friendly commands like this. I hope I don't have to explain that this is a very dangerous shell script. Now, in order to make it an executable script, which by default it isn't, I need to do something else. First, let me save this shell script. Now, in order to make it an executable script, which by default it isn't, I need to do chmod on it. So I'll do chmod plus x game. And then I do ls-l, and we can say that now the script is executable. You can imagine as it's a bad idea if I run it as a root. But let's do it as user Lisa. So I go cu-Lisa to become user Lisa, and then I do a ls now. Let's now run the script. Let's now see what happens if we run the script. Hi, do you want to play a game? What is important to understand is what is going to happen when Lisa is actually going to start the game. Basically, what happens is when Lisa starts the game, the script is trying to remove any files. It will do it as Lisa and no one else. The worst thing that can happen is Lisa's home directory is wiped and everything else will be gone. So you understand how dangerous that is? So you should be very careful while doing such things. So now let's exit from the terminal. Now let's set the set UID. In order to understand let's set user, we have to look at the properties of the file. We can see that it's owned by the user root and the group root. Set user ID means that if the file is executed, it will execute as the owner of the file. And so to set user ID, I will do chmod u plus s on game. I'll do an ls-l. And as you can see that it's marked in red, which indicates that something very potentially dangerous is going on. And now let's become Lisa again. And Lisa sees this file again and starts the script again. Can you imagine what's gonna happen? That's why you don't want to set user ID anytime. Set user ID is never solution for a problem. Don't use it ever. Set user ID is only applied to some system files. Let me show you that. To find those files, I'm using find command. So let me go to the find command. Excuse me, I'm sorry. So let me go to the find command. To find those files, I'm using find/-perm, which will find files based on permissions /4000, which means that the first digit in the permission settings must be a 4, which you have just seen. The set user ID and the other ones we really didn't care. We see a couple of error messages, and then we see a list of files that do have set user ID for very good reasons. One of the files is user bin password. That's the binary that allows users to change their passwords. Let's analyze it. Let me do ls-l on that file. And how we do that? ls-l user bin password. First you can see S on the position. You normally see an X for user indicates the set user ID. Now why does passwd has set user ID? That is because the password has been written to the etc shadow file. And as you can see, there is no permission whatsoever on the etc shadow file, which means only root can access etc shadow file, which is good. But if the user wants to change the password, it has to be written anyway to the etc shadow file. and that's why user takes root permissions at the moment user bin password is running. And there is nothing wrong, as password is well written program and it's securely being analyzed, and there is nothing wrong with it. So basically there are some system binaries that contain set user ID and keep it like that and never try to use it. Set user permission on anything else. As you have learned, there are two other permissions that are important. I have explained set group ID, which is basically same as set user ID. You're not going to use that. What you're going to use is a set group ID on directory. And so let me show you how it works. First, I need to change my user from root to Lisa. So now I'm becoming Lisa. So I'll do su. First I'll do ID Lisa. Now I don't want Lisa because we see that Lisa is member of the groups, and given the fact that group account is group owner of the directory and group account is read write. See, as you see there that the account group has read write execute permissions. So now what I'm going to do is su super user Lisa before do, and given the fact that group account is the group owner, let's try to write a file on the Lisa1. Let me do an ls-l, but we see that the file is being created with a user that created the file, who's the user owner and the primary group owner. Now what's wrong with it is that the other members of the group account don't really have any write permissions to the file, and that's not really useful in a shared group environment, and that's why we have set group ID. So let me do chmod g+s on the account directory. Chmod, oh, I'm sorry, I needed to exit from Lisa to chmod g+s on the account directory. Then we do ls-l. After doing ls-l, where normally access for group, let's become Lisa again and go to the data account directory. I'll write another file called Lisa2 by using the touch command and do ls-l, and as you can see that the file is automatically owned by the group account. This is something very important when it comes to daily administration tasks, because in an enterprise you'll be asked to set up a shared group environment where all the members of the group will automatically get write permissions to any file created in a shared group environment. You'll do that by using the set group ID. Now let me talk about sticky bit. You know what sticky bit is? Well, you are about to know. Sticky bit prevents the users from deleting files which they don't own. So if the sticky bit is set on a directory, a user can only delete the file if the user is the owner of the directory, or if the user is the member of the directory. So let me check if there is anyone else using the group account. So what I'm going to do is grep account on etc group, which will help me to find out what's in there. We have Laurie, and Laurie is a member of the account. So let's do su Laurie, and as Laurie I go to the data account, and now I'm going to create some files there. You can see that group ownership is set correctly. Now that will be interesting. Is Laurie is allowed to execute or remove rm-f on file Lisa1? That is the remove command. Of course, yes, because he's the member of the group account, and the group account has write permissions to the directory. Write permissions to the directory mean you can delete anything in that directory. Now the question is Lisa going to be happy with it? Probably not, and that's why we need sticky bit. I'm just doing the chmod on the directory plus T on star. Sticky bit is something you'll want on any shared group. You can see an uppercase T where there is normally an X. For others, it's an uppercase because there is no X behind it. It's just sticky bit. It will be a lowercase if it has X behind it. Same goes for the set group ID that we see here. On the directory, it has a lowercase s because it has x behind it, and it would have been uppercase s if there was no x behind it. So we become Larry again. So in order to become Larry again, I'll do su Larry. We go to the data count. We see some files. We'll do rm-f, that's the remove command on Lisa2, which is going to be allowed. Why is that? There must be a reason. No, you see that Laurie was the owner of the directory, so she is allowed to remove any file from the directory. Let's do it as Lisa now, which makes more sense. So doing this as Laurie was a very bad example. So in order to do it as Lisa, I'll exit the terminal. I'll log in as Lisa by su Lisa. I'll go to the data count and I'll use the remove command rm-f on Laurie1, which is not permitted because of the sticky bit. And that's why sticky bit is something you want on any shared group environment. Now if you do ls-l, you'll see the little t on the tmp directory, because tmp is a directory where anyone can write files. That's all you need to know about managing special permissions. Thank you for bearing with me.